Hello, so today we are going to integrate the procedural aiming code from my asset into the Advanced Locomotion System, or ALS, version 4. My asset's latest version is version 2.2.0, and we are going to use Unreal Engine 5.2.1. But this should work the same in Unreal Engine 5.1, 5.0, 4.27, 26, 25, and 24. You can find the links to the ALS project and also my project in the Marketplace. You can find the links in the video description below. I find it easier to do this integration in Unreal Engine 5 because in Unreal Engine 5 you can copy-paste variables and functions much easier than in Unreal Engine 4, and also curves from inside animations. You can do this easier in Unreal Engine 5 since you can copy-paste the entire curve at once. In Unreal Engine 4 you must copy each keyframe individually, so you can do the same, probably can do the same thing we are going to do here. You can do this in Unreal Engine 4 too, but it's just more laborious. We are going to implement everything from the procedural aiming project except the reload while aiming, because the reload while aiming implementation works very well in the true first-person implementation of the Sugar procedural aiming project, but ALS uses a different implementation of true first person. So when you reload while aiming with that technique, it's not as accurate. So we have to choose which option from the procedural aiming project to use in the ALS project. We have 4 options here. 2 are for arms only characters and 2 are for full body characters. ALS uses a full body first person character, so we need to choose between project 1 and project 2 for full body. I think that project 2 might be easier to integrate in ALS since it uses only 2 virtual bones instead of 3 virtual bones. So we will migrate this folder into the ALS project, and this folder doesn't contain any references to any of the content of these other folders, so we can just migrate this folder alone and nothing will come along from the other folders. So let's do this. Migrate. You can see everything we are migrating are only in the full body project 2 folder. Yeah, that's right, content, select. So we already migrated, we don't need this project open anymore. Now inside ALS we have just our full body project 2 folder. So before we proceed, let's talk a little bit about the working of the procedural aiming system. It assumes that you have a character and that you have a gun attached to the hand of the character, and also that you have a first-person camera attached to the head of the character. So it works by moving the hand of the character that has the gun to a place in front of the camera in which the sights of the gun are perfectly aligned and centered in front of the first person camera. And for optimization purposes, it assumes that the gun, after it's attached to the hand bone, it is fixed in position. It doesn't keep moving in relation to the hand bone. And also the first person camera, after it's attached to the head bone, it's also fixed in relation to the head bone. It doesn't keep moving in relation to the head bone. That makes things a bit easier because we only need to do the calculations once after we attach the camera to the head and the gun to the hand. We only need to run the calculations once. We don't need to keep repeating every frame the calculations because the result will be the same. But there are projects, especially sophisticated projects like ALS, in which both move. Both the gun moves in relation to the hand bone after it's attached, and the first person camera is always moving in relation to the head. So we need to adapt the code so the calculations are done every frame, so we always have the correct values. But what's the actual performance impact of calculating this every frame? It's pretty unnoticeable. Let's show the performance of ALS here without the integration. So original ALS. Let's first set the max FPS to 1000, otherwise Unreal caps the frames per second to 120 frames. T-point max FPS 1000. Step unit to show the milliseconds, and some people like to see the FPS. Step FPS. What we need to look here is the game thread milliseconds, because the FPS is being limited by the GPU time. In our case, the GPU is the slowest part on the chain, so changing the code that affect the game thread won't make any difference in the FPS, because the FPS is being limited by the GPU, which is being slower here than the game thread. So we need to see the difference in game thread milliseconds between the when we are playing the original ALS and in the already integrated version of ALS, in which we are doing the calculations every frame. So let's play it. Problem here is that this menu gets overlapped with the information, but in the video I'm going to zoom in here so it's easier to see the game thread. So maximize it, and the game thread is about 7 point something milliseconds. When I move, it goes to about 8 milliseconds. That's normal. And I'm going to first person mode, select my rifle, and I aim, move about 8 milliseconds, 8 point something. Now let's go to the integrated project. So here we are in the integrated project, about 7 point something milliseconds too. I can't see exactly the value. We move, we go to about 8 point something. Let's go to first person, select rifle, move a little bit, aim down sight. Move. It's also in the 7 point something, 8 point something milliseconds, so it's a very minimal impact on performance, and that's partially because I'm only doing this on the player character. I'm not doing the calculation on those characters because it's not needed for the AI. You don't, unless you want, you don't need to place the sights of the gun of the AI characters in front of their eyes. They don't even have a camera for them because they are AI. And if you're doing a multiplayer game, you actually also only need to do the calculations for the local player. You don't need to do the calculation for the enemy players, even if they are human players, because their calculations will be done on their computers. You don't need to do the calculation for each enemy player on your computer too. But there are cases in which you might want to run the calculations for each character, each enemy character. For example, if you want to see exactly from which side they are aiming, you might want to run the calculations for those guys too. But there are cheaper options in this case. You might, for example, have a different aiming animation pose for each side of the gun, and then you don't need to run any calculations because the sight doesn't actually need to be aligned with their eyes. They don't even have a camera. So I guess that would be a cheaper solution in terms of performance than run the calculations for every character, especially if you have many characters in your game at the same time. Or if you're using, I guess if you're using C++ and you're porting the code, because this code is all done in blueprints, but if you're making a C++ project, you're migrating, you're porting this code to C++, then I guess you can have this running for every character and have a big amount of characters, and it wouldn't have a noticeable impact on performance. But in our case here, we're just running the calculations for the player character, local player character, not for the AI, and we are only running the calculations when we are aiming. So right now I'm not calculating anything because I'm not aiming. Now I'm calculating. And if I, for example, have the binoculars and aim with them, I'm not running the calculations too. I'm only running the calculations when I have the rifle or the pistol in my hands. Also, if I have the rifle or the pistol and I'm in third person view, I'm also not running any calculations because I don't need, because I'm in third person. But if I'm in first person, then I'm running the calculations. And for information, my CPU is an i5 9400F and my GPU is an RTX 2060 Super. So let's start the integration by creating the aimpoint sockets in the gun mesh, so the blueprints know where the sights of the gun are in the gun mesh. So ALS has two gun meshes, one pistol and one rifle. Let's start with only the rifle. It has a front sight and a rear sight. We need to place a socket here and another socket here. So in which bone we are going to place the socket? There's a bone called sight. If we move this bone, we can see that both sides belong to this bone. So let's place the aimpoint socket on this bone. So the socket will move if the bone moves. So add socket, and we need to name this rear aimpoint. And we need to make the x-axis of the socket point forward and the z-axis of the socket point upwards. So let's rotate it 90 degrees. Now it's oriented correctly. We just need to place it at the center. Looking at the tip of the arrow is useful to help you aligning it. and we can copy and paste. And this one is going to be the front endpoint. And the front endpoint, we place it on the front side. Looks alright. Control S to save it. The naming of the sockets is very important. They have to be named like they are here for iron sights. If you had an optic sight instead of iron sights like we have here, you'd have to make a socket named optic endpoint. But later we will add an optic sight to this gun and we will see that. Now we have to go to the blueprint that has this mesh component and add the tags to it. The tags are important because they define the order in which you cycle sights in case you have more than one sight on your gun. So you could have a gun that's not just this mesh, it has other meshes that has optical sights and other sights, and the tags give you the opportunity to define in the blueprint the order in which you want to cycle through the sights. In the case of ALS, the mesh component of the gun is in the character blueprint. So we go to the character blueprint. And we select the mesh component. In this case, it's a skeletal mesh component that the ALS character has. And we can't see it because right now the mesh is set to none, but when you're in game and you select rifle, it sets the mesh to be the rifle. And here it is. So on this skeletal mesh component, you go to the tag section and we add two tags here. One is going to be front sight _0, and the other one is rear sight _0. This naming is important. It's 0 at the end because it's the first sight that we want in the cycling order. If we have more sights on this gun, we would give the number, the appropriate number to define the order of cycling. So 0 is always the first, 1 is the second, and so on. And you can't skip numbers. So if you have two sights, you can't name them 0 and 2, for example. We have to name them 0 and 1. Now let's go back and reset the mesh so it's invisible again. Compile and save. So let's start copying code from the procedural aiming blueprints into the ALS blueprints. Let's take a look at the character blueprint. First off, we got some warnings because the input events in the procedural aiming project were named differently than the input events in the ALS project. Remember, we copied this blueprint from one project into another. So in the procedural aiming project, the move forward input was called move forward. But if we look in the ALS project, input the move forward input event is called move forward slash backwards. So move forward doesn't exist inside the ALS project. Same with move right, turn and stuff. But we don't need to worry about that because we are not going to use this character. We're just going to copy the code that we need from inside here and place it in the ALS character, and the ALS character already has all the inputs that are needed. Also, the blueprint is divided in 3 sections. The gray section is code that is usually present on shooter projects, like input for movement, mouse input, fire input, reload input, aiming input. Cycling sights, maybe you don't have it in your project, but you can just create it very quickly. And a escape button menu to let you exit the game. None of this stuff is important, and you probably already have it in your project. Also, here we have in the blue box stuff that's not necessary, like for example camera shake when you fire. You might already have this in your project. It's not essential for the working of the procedural aiming stuff. More functionality for zooming in and out and heads up display. The ALS already has an HUD display. We don't need to copy the code for that. And cycling between the cameras, so if you want to have a side view, a front view, and back view of your character, just for debugging, and there's code here for that if you want, but we don't need to copy these, and ALS already has stuff like that in it. What we need to worry about is the stuff that's in green, and still most of it you already probably have them in your project, like a reference to your animation blueprint. Like if you don't, you can copy these if you don't have it already in your project. This is where the most important stuff is. I'm going to come back to this in a minute. Here we have, when we press the fire button, we are just telling the animation blueprint to run its fire code. When we press the reload button, we are just telling the animation blueprint to run its reload code. When we press the aim button, we are doing a check to see if our gun even has sights. If it doesn't have sights, then we don't aim, we just print a message on screen. And if it does have sights, then we tell the animation blueprint to start aiming. And when we press the cycle sights button, we're just telling the animation blueprint to cycle sights. So the character blueprint actually doesn't have anything important. The only thing that it has that we need is here inside the add gun node. This is connected to the event begin play that you probably already have in your project too. And when we begin play, we spawn the gun. We don't need this code in the ALS because the gun is already in the character blueprint. We don't need to spawn a gun. We don't need to attach to the hand because in the ALS character the gun is already attached to a bone that's in the hand. And here in the post attach that we have the most important call, which is a call to the animation blueprint CalcHandTransforms. This is the function inside the animation blueprint that will calculate the position of the sights of the gun, if the gun has sights. And then we are also here accessing our gun blueprint and extracting some values like the time to aim down sights and sending it to the animation blueprint to be used. But in the ALS, there isn't a separate gun blueprint. The gun is inside the character, so we won't need this. We won't use this. We're just going to use this in the ALS character. And even so, this function isn't in the character, it's in the animation blueprint. So we need to create this function inside the animation blueprint of ALS and then place a call for it in the ALS character. So let's go to the function in our animation blueprint. Let's double click here, and this is our animation blueprint, and we are inside the function, and the function is listed here on this panel. We can right click on it and copy. But if we go and paste it now in the ALS blueprint, in the ALS animation blueprint, it's going to complain that it's using some variables here that aren't present in the ALS animation blueprint. So let's first copy the variables that this function needs and paste it in the ALS animation blueprint, and then we can copy the function over. The local variables of the function will be copied automatically when we copy the function, so we don't need to worry about the local variables. We just need to copy the variables of the blueprint. So what are the variables that we need to copy now? It's the hand transforms, copy, and paste variable. I'm going to create a new category for these variables that I'm copying from the procedural aiming. I'm going to name it SPA from shooter procedural aiming. All the variables that I copy from there, I'm going to place inside this category for organization purposes. What else? Current site. By the way, right clicking here and copy and pasting, you can't do that in Unreal Engine 4. You need to manually create these variables and the functions inside the ALS animation blueprint. So it's a bit easier here in Unreal Engine 5. Copy and pasting like this is good because it already comes with the description, description field, and it already comes with the default value. For most of them it's 0, but if it's not 0, you don't need to set them in the ALS animation blueprint. Compile and save. Then I can copy the function itself. Paste function. I'm going to create a SPA category named SPA for this function too. I compile, I'm gonna get some errors. One note here is that when you have collapsed nodes like this one inside functions, I'm inside the CalcHandTransforms function and I have collapsed blueprint nodes here. If the function has local variables and these variables are used inside collapsed nodes like this one, it's using handTransform, which is a local variable inside the CalcHandTransforms. If you rename the collapsed node, like for example, I want to remove this number 2 that Unreal added when I copied, and I compile, it's not giving me the error because I think it's fixed in Unreal 5.2, but I was getting this error before. It stops recognizing this variable. It will give you an error on this variable. So if you get that, you right click on the variable and choose replace the variable with itself. It's not appearing here because it's not giving me errors, but if I was getting this error, the hand transform would appear here in the options list. So I would just replace hand transform with hand transform, and then it would fix the error. Then you do that with every node, every variable node that's giving you the error. Let's check the first error. So this is because in the shooter procedural aiming project, the character has a variable named gun, and the gun has a variable named distance from camera inside of it. But in the ALS project, the character doesn't have it. So we can delete these, and we are going to create a distance from camera variable inside the ALS character, because the ALS project doesn't have a blueprint for the gun, a separate blueprint for the gun. The gun is inside the character blueprint. So we are going to the ALS character and create a variable of the type float named distance from camera, must be float. Compile, and the default value can be 0, so save it, and let's create a category for it as PA like before. Now we can get a distance from camera from our character, but since this variable is of the type character, just character, it doesn't have this variable because this variable was placed in the ALS Anim character, not in the Unreal's default character. So we need to cast it, because if we try to get distance from camera here, we don't get anything. But if we cast it to ALS Anim, and we can convert this to pure cast because we don't need that big node. Now this is the ALS character, and this one has the distance from camera variable. So get distance from camera. Now we can connect this to this, and we can delete these. File and save. Now that error is gone. Let's go to the next error. again, the character from the shooter procedural aiming had a FP camera variable in it, and the ALS character doesn't. So the ALS character doesn't have a camera component actually. So we can we should replace this with the camera manager. So get player camera manager, and from here we can get the camera location, get location, and the camera rotation. And we can make a transform from these two. And then we can connect this instead of this, and we can get rid of that. So next error, again the character variable. So instead of grabbing the gun variable from the character, we will get the character itself. File, save. Next error, again the same error, but now we're on a different part of the code, so we're going to do the same. Compile, save, and next error. Again the same error as before. And the last error, same as before but in a different part of the code. We'll connect these straight in because we are getting the mesh from the character and not from the gun blueprint, because we don't have a gun blueprint in ALS. And since the camera isn't fixed in relation to the head bone anyway, and we are going to calculate these values every frame, we don't need to convert the transform to the headspace, we can go here and here and connect this directly to here, so we can bypass some nodes, so there are less nodes to be used. And we do the same in the iron sights. Compile and save. Now the function is ready, but we need to call it from somewhere. And I want to call it every frame, but only when I'm aiming. So where can we call this from? Luckily ALS has this update graph here that gets called every frame, and we can see these functions being called. One of them is named update aiming values. So let's go inside here, and it has these switch on nodes that lets you execute stuff if you want only when you're aiming. So for example, if I drag a pin out from the aiming output, anything that I execute here will be executed only when I'm aiming, but every frame. So this is a place where I can call my CalcHandTransforms function from. So let's find a empty place here just to test this. Remember that I only want to call this when I have my rifle in my hands too. And ALS has an enum variable called overlay state. And it can have several values. One of them is rifle. So when overlay state is rifle, it's because I have the rifle in my hands. So I can do a switch on here too. And if I expand this, I can drag from the rifle, and only when I have the rifle in my hands, it's going to be executed. So let's connect here and here. But I also only want this to be executed when I'm in first person mode. So there's another enum in ALS called view mode, I guess. Get view mode, and I can do a switch on here too. And can connect it here, and if I connect just the first person output, now it's going to be called only when I'm in first person. And I also only want to call this for the human player. So I can grab the character here and get his controller. Now if this is a player controller, it's because this character is a human player, and if this is an AI controller, it's because this is an AI character. So I'm going to try to cast this to a player controller. I'm going to cast to ALS player controller. And if this is a human player, this pin will be executed. If this is not a human player, this pin will be executed. So I won't connect this pin. So let's test this by connecting a print string node here. print call. Let's go to 11 and play. Not printing anything. If I grab my rifle, still not printing anything. I'm gonna aim, it's not printing. Go to first person, now it's printing. And stop aiming, stop printing. Now we need to copy the necessary virtual bone to the ALS skeleton. If we take a look at the skeleton provided with the procedural aiming asset, it has two virtual bones that we use to animate the hands procedurally. But the ALS character, it already has some virtual bones for the hands that the ALS itself uses in its own system for procedurally animating the gun. And those bones are used in an actually different way than we use them in the procedural aiming project. So we actually only need to copy the virtual bone for the right hand, because the virtual bone for the left hand, it only serves in the procedural aiming project, it only serves to keep the left hand in its right place on the gun. But ALS already has a system for that. It uses this bone in the animation graph. There is an IK node that uses that bone, VB, RHS, IK, and L. VB, RHS, IK, and L. Uses this as the target for the hand, the left hand bone, and it keeps the left hand in its right place all the time. So we should take advantage of that and only copy this bone. Actually, we can't copy, so we just add it in the ALS mannequin, just like it was added in the other mannequin. So as a child of the head, add virtual bone, and we pick the target bone, which has to be the hand R bone, and we rename it to VB hand R, and save the skeleton. And that's all we need to do to the skeleton. You can close this and close this. So now we already have our virtual bone in the ALS skeleton, and we already have our CalcHandTransforms function giving us the right values, hopefully. And we need to use those values in the animation graph to actually move the hand bone and align the sights, because it's in the animation graph that the bones are moved. But where should we place our code in the Anim Graph so that it is the least invasive in the ALS system and that it still works? So ALS has a aiming state right here in the beginning, the overlay layer, overlay states, rifle, and rifle states, rifle aiming. So this is the code that gets executed when you're aiming the rifle. So we could place our code here, and it should be the least invasive, but I already tested this. The problem is that if we place our code here, after this we have this code being executed, and it's moving the character's spine, and as a consequence the head and also the arms and the hands. So our sights get misaligned here. To be sure that our sights are never misaligned after we run the code, we could place our code here at the end of the graph. The problem with that is then our character would be always aiming down sights. And here near the end of the graph there is this node that executes ragdoll, and ragdoll only executes when you're dead. So if we place our code here after the ragdoll, our character would be trying to aim down sights even when it's dead, and we don't want that. So we could place it before the ragdoll. The ragdoll won't interfere with us because it only happens when we are dead. But before the ragdoll there's the foot IK, and the foot IK also doesn't interfere with the hands because it only affects the foot. And what comes before the foot IK? We have the hand IK. This does interfere with the hands, but I already tested it, and I'm going to show the difference between adding it after the ALS IK system right here or before this system right here. So what are the values that we need to grab from our function to use here in the Anim Graph? Let's go to the function CalcHandTransforms. Let's go to the end of the function. Those are the two values, hand location and hand rotation, that are being set at the end of the function. And we need to use those values in the Anim Graph to place the hand bone at the right place when you're aiming. So let's go to the Anim Graph, to the variable section, and grab hand location and hand rotation. And we need to feed them to a TransformBone node. And this node must be set to move the VB hand R bone, which is our virtual bone. And translation mode need to change from ignore to replace existing, and the space must be the world space in our case, because those values are being calculated in the CalcHandTransforms function in world space. So the space must be the same, world space. So same for rotation, replace existing, and world space. So now that we are moving the virtual bone according to these values, we need to use an IK node that will move the actual hand R bone according to VB hand R. So we are going to use a TwoBoneIK, and the IK bone is the hand R bone, and the effector, which is the bone that we are going to use as target, must be bone space. Let's take rotation from effector, and the bone will be our virtual bone. So let's make a quick test. We will fix this later. So it seems to be aligned, but there are some problems that we are going to fix. First of all, I want to add some kind of crosshair in the middle of the screen, so we can make sure that this is actually aligned in the middle of the screen, and the gun is moving, so it's never really aligned. So I want to kill this movement. So first, let's create our crosshair. In the ALS folder, let's search for widget blueprints, because I know it already has a HUD widget. ALS HUD. So let's drag an image here, anchor it to the center of the screen, and 0 its position. It's aligned by the corner. We want to align at the center, so alignment must be 0.5 on the x-axis and 0.5 half in the y-axis and half in the x-axis, so it's aligned by the center. And we want it to be square, not a rectangle, so size x must be the same as size y, 40 and 40, and it's too big. I'm going to use 4 pixels and 4 pixels. And I want, by the way, if you use an odd number instead of an even number, it will never be really at the center, because there is no pixel at the center of the screen, because the screen usually has even number of pixels. So it's a good idea to use an image with an even number of pixels, both on x and y. This way it can be really at the center of the screen. And I want to change the color to green. Seems to be alright. Now we have our mark in the center of the screen. The gun is trying to be at the center of the screen, but it's moving, so it's never really at the center of the screen. We're going to solve that. So the problem is that even though we are running the calculations every frame, so we have always the most updated values to feed to the animation graph. Our calculations are being fed with values from the camera manager, player camera manager, and from the get socket or get bone or get socket transform functions inside the CalcHandTransforms. And these values that are being fed to the CalcHandTransform function, they are being updated by the engine at different points in time at each frame or each tick. And the animation graph also gets executed by the engine at a different point in time during each tick or each frame. So this animation graph is probably being executed before those values that are being fed to a function are being updated by the engine, and this is probably causing a one frame lag. So what we must do is we must make sure that the animation graph is only run after all those updates are done by the engine. So how can we do that? We go to the character blueprint. Remember, this animation graph, it runs for the mesh component of the character blueprint, and this mesh component has a tick related variable. If you search for it, tick, it's called tick group, and if we choose post-update work, it is the last point in time at which the tick for the mesh component of the character will be executed. So if we change that, apparently we changed the point in time at which the animation graph is executed. So if we test now, now it's not moving anymore. So that's what we want. No lag, no movement. And if we want to add sway, then we add the amount of sway that we want. So the problem is that even though we are running the calculations every frame, so we have always the most updated values to feed to the animation graph, our calculations are being fed with values from the camera manager, player camera manager, and from the get socket or get bone or get socket transform functions inside the CalcHandTransforms. And these values that are being fed to the CalcHandTransform function, they are being updated by the engine at different points in time at each frame or each tick. And the animation graph also gets executed by the engine at a different point in time during each tick or each frame. So this animation graph is probably being executed before those values that are being fed to a function are being updated by the engine, and this is probably causing a one frame lag. So what we must do is we must make sure that the animation graph is only run after all those updates are done by the engine. So how can we do that? We go to the character blueprint. Remember, this animation graph, it runs for the mesh component of the character blueprint, and this mesh component has a tick related variable. If you search for a tick, it's called tick group, and if we choose post update work, it is the last point in time at which the tick for the mesh component of the character will be executed. So if we change that, we change the point in time at which the animation graph is executed. So if we test now, now it's not moving anymore. So that's what we want. No lag, no movement. And if we want to have sway, then we can add the amount of sway that we want in a controlled manner. Another problem that we are having is that our hands are out of place when we are not aiming. That's because those two nodes are only meant to be executed when we are aiming, and when we are not aiming, those nodes shouldn't be active. Ideally, we would have solved this problem if we placed these nodes inside that rifle aiming state that I showed before. But since we can't do that, we can use these alpha values to turn off these nodes when we are not aiming. So alpha, when it's 1, the node is active, and when it's 0, the node isn't active. So we can take advantage of that and create a variable here, promote variable, and I'm gonna call this sight align alpha. Place it in a category, and by default I want this to be 0, so it's inactive. Every node that's connected to it is inactive. Let's find more space for us here. Later we make this more organized. And now we need to set this to 1 only when we are aiming. So let's go to our update aiming values, and here when we can delete this, and when we are running the calculations we will set that sight align alpha to 1. So let's grab sight align alpha and set it to 1. But when we are not calculating this, when we stop aiming, we must return sight align alpha to 0. So we must drag this again and set it to 0 and connect every other possible path that isn't the rifle aiming to this. So when we get to this stage and we are not aiming with the rifle, we are going to return sight alpha to 0. Remember that this gets executed every frame. So not only here, we're going to have to connect all these other pins. Ideally, for organization purposes, we could use another switch on rotation mode node, place it here, but for now let's just test this. So our right arm seems to be fixed. And the other problem we have is this left hand that's not fixed at the gun. So let's solve that. So as I said before, ALS has its own hand IK system, and we are running our code after it, so we are not really taking advantage of it. So we can try running it before, and we will take advantage of the left hand IK system. So let's do that. So let's test this now. So it seems to be aligned correctly. We are running, now we're walking, crouch it, uncrouch it, running. Except when you walk on irregular terrain like this. This is weird. And when we jump, it also gets misaligned and don't realign after we landed. We have to do some debugging to find this problem. After hunting down this problem and scratching my head a lot, I found out that the problem is here in the TwoBoneIK node. If we bypass this node like this, compile and play, now we don't get the problem. And we can jump too, and it doesn't misalign. But the problem with this is that if we are in third person and look at our feet when we are on irregular terrain, our feet is kind of floating in the air. So disabling the TwoBoneIK solves the side problem, but I don't like to do that in ALS, because one of the key points of ALS is having an animation that looks very realistic and looks very nice and foot placed correctly. I mean, it's not a great deal if you want to disable this. If you look at many games, they have these feet floating in the air when you're on irregular terrain. This is not a terrible thing to have, but if you're using ALS, if I'm using ALS, I don't want to disable this feature because it looks so nice when you have the feet placed correctly. So I guess you can, if you want, disable the TwoBoneIK only when you're in first person, so you can barely see that your feet are floating in the air. But the problem with this is if you have multiplayer, then when you're aiming, the other players will be able to see that your feet are in the air from outside. I guess you can, to solve that, you can enable the TwoBoneIK only for, you can disable the TwoBoneIK only for the local player when he is in first person. This way nobody will see your feet in the air. But there's also another solution which I'm going to show, which is we are going to keep our TwoBoneIK all the time, but we are going to compensate that in the aiming so it doesn't get misaligned. So let's reconnect the TwoBoneIK, and if we go into the TwoBoneIK code, the cause of the problem is here in the pelvis TransformBone node, because in order to be able to reach the ground, for the foot to reach the ground on irregular terrain, let's say we're walking on irregular terrain and here the ground is down here, so our leg doesn't have the length to reach down here. So this code moves the pelvis a bit downwards, so your foot can always touch the ground. If the ground is higher, your pelvis will go up a little bit. If the ground is lower, your pelvis will lower a little bit. And if we have this node connected and working, and we disable this this TransformBone for the pelvis alone, this will look even worse because your leg will stretch a lot and it will look broken. So what I can do is I'm going to apply whatever offset we are applying here to the pelvis. I'm going to apply this to the hand, to the right hand too, so it will always be aligned even when we are on irregular terrain. So we need to go to our CalcHandTransforms function, and we go at the end where we set the hand location, and before we set the hand location we add the pelvis offset. Actually you have to subtract, not add, so I'm going to pull from here and subtract, and I'm going to find my pelvis offset here. The pelvis offset variable, I'm going to connect here, and connect to hand location. And one more thing is that this is being called, the CalcHandTransforms is being called here inside the update aiming values, but the pelvis offset is calculated here inside the update foot IK. If we go here and go inside set pelvis IK offset, we can see that the pelvis offset variable is being set at the end. So if we keep calling CalcHandTransforms here inside update aiming values, we are not using the updated pelvis offset value. So I need to cut this code from here and paste it after the update foot IK function is executed. So let me select this, Control X to cut, and go back here in the update graph. After the foot IK, I'm going to Control C to paste, and I'm going to connect it here, and both paths should be connected here. So it goes from here, and every possible path is being connected here. Let's compile and test this. Oh, and one more thing that I forgot is that we must execute this only when we are aiming. Here we already had this connected only to the aiming pin, and we have to do this here too. Have to get rotation mode, and do a switch on ALS rotation mode. And instead of entering here, we are entering here, and only aiming gets connected to this code, and the rest goes straight here. So compile, play. And now if we go in irregular terrain, there's no issue of alignment. And if we jump, there's a slight movement when we take off and when we land, but it goes back to normal, so no issue there. And now if we go to third person mode, we get to keep our foot position because we have our foot IK nodes working. Now let's make it a little more organized by collapsing this to a single node. So collapse nodes. Let's call this SPA side align. Let's go inside. Let's make this pretty. So here is when we are aligned and here is when we are not aligned. So I'm going to name it align and not align. And I'm going to move it down. I'm going to leave it up here so we can easily find what we inserted. Another thing I want to address is that we have no transition between not aiming and from aiming and not aiming. It's just snapping. We press the aim button and it snaps. Then we release the aim button and it snaps back. So let's make a nice transition. So here in the animation graph, we are turning on and off these nodes with the sight align alpha variable. When sight align alpha is 1, the nodes are on, and when it's 0, the nodes are off. But sight align alpha goes from 0 to 1 instantly and from 1 to 0 instantly. But these nodes have a built-in interpolation option here in the alpha section. So I can turn on interp result on this node and on this node, and it even has an option to set the speed that you want to make the transition. But 10 looks like a nice speed, so let's test this. Much better now. So this is a nice and simple way to control the aiming speed, but the limitation with this is that we are stuck with just one speed for all weapons when we are playing, because these nodes don't have an option to connect a variable to these values. So whatever value I set here is going to be used by whatever gun we have. So for example, if I have another gun that is supposed to have a faster aiming speed, I can't have that. It will have the same aiming speed for all guns. So instead of using this alpha variable, I'm going to use a blend by bool node. And I'm going to need a boolean variable here, which I'm going to call align sight. To the true poles, I'm going to connect this, and to the false poles, I'm going to connect these. So the problem here is that the input of this node is not connected to anything, and it was connected to the output of this node. But now the output of this node is connected here straight to the false poles of the blend posed by bool node. And we need two wires, one coming out from here straight into here, and another one coming out from here going straight into here. But in the animation graph, we are not allowed to have two wires coming out of the same node. For example, if I get this and connect here, now the other one gets disconnected. So every output pin can only have one wire connected to it. The solution to that is to use the cache nodes. So I'm going to drag from here and type cache, choose new save cached poles. I'm going to rename this to post spine, because it comes right after the spine rotation here. And whatever is fed into this node can be retrieved by using another cache node, post spine, and I can have duplicates of these, as many as I want. So one of these I'm going to feed into here, and the other one I'm going to feed into here. Just going to do some organization here, and now I can have variables to control the speed of aiming connected to the blend input of this node. So the time to aim down sight is set by this value here, which I can connect a variable. I'm gonna call this variable time to aim, and default value of 0.1 is okay. And I'm gonna do the same thing here, promote to variable. I'm gonna call this time from aim, and a value of 0.1 is okay too. Now that we are controlling aiming with the align sights boolean, we don't need this sight align alpha variable anymore. So let's delete this. I'm going to make a search to see where it's used. It's used here, so let's delete it. And we don't need the interpolation option on these nodes anymore, so I'm going to turn it off here and here. And it's also used here and here. So we are going to replace this with the new boolean variable. So when it was being set to 1, the boolean will be set to true, and we can delete this. And when it was being set to 0, we will set the boolean to false, and we can delete these. Let's test. If I change the value of time to aim, for example, to something higher like 0.5. Now it takes a much longer time to aim. Now let's add the fire animation. The ALS project doesn't have a fire animation, so we are going to use the fire animation sequence included in the procedural aiming asset. So let's go to the procedural aiming folder, filter by animation sequence, and here is our fire animation. Now this animation is using the mannequin skeleton included in the procedural aiming folder, but the animation blueprint of ALS uses a version of the mannequin skeleton included in their folder. So in order to use this animation in their animation blueprint, we are going to have to change the skeleton to their skeleton. But I don't want to mess with the original, so I'm going to create a copy of this animation sequence, duplicate, and I'm going to name it ALS. Now I can just click here and replace the skeleton, but the problem with doing this now is that this fire animation is an additive animation, which means that it specifies a base animation, because the additive animation runs over a base animation, and the base animation for this one is the idle that's included in the procedural aiming. And if we change the skeleton of this animation now, it's going to Unreal will automatically also change the skeleton of this this idle animation. So we're going to duplicate this first. So let's go back to the folder, find the idle animation and duplicate, and I'm going to name it ALS2. Now when I go to the fire animation ALS, and I'm going to replace skeleton, and this is the skeleton of ALS. We can see in the folder path that it's in the ALS folder, so I'm going to select this. And it changed both the fire animation and the idle animation that it is running over. So this one had the skeleton changed, this one also had the skeleton changed, and this one didn't. So I just have to fix the names quickly here. This is going to be the ALS idle, and this is the original, actually. Working with additive animations can be a bit confusing. That's because for the fire animation we must have a base animation, which is this idle here. But when we are playing the game, we are never going to actually play this idle animation. We are going to keep playing the ALS idle animation. So what's really happening when we play the game and when we use this fire animation is that since it's additive, it's not going to play all its bone movements. It's going to look at the difference between the movement of the bones in this animation and the movement of the bones in this animation, and it's going to only apply this difference of movements, and it's going to apply this difference over the base ALS idle animation and not this animation from my asset. The advantage for us is that we will keep the ALS position of the hands on the gun. because the ALS animations were made for the ALS gun, and this fire animation from my asset was made for a different gun. And if we just play this animation in an absolute mode, not in the additive mode, it will change the position of the hands and it will look weird because it won't match the ALS gun. So using this as an additive animation, we will preserve the original ALS hands position on the gun. Now we need to create a animation montage out of this animation sequence. So we are going to right click and create any montage. I'm going to name this AM for animation montage. And in order to be able to view the animation in the animation viewer, we need to tell this what base animation it's using, since this is an additive animation. So let's find the idle ALS, and we are going to play this only on the arms bones. So we are going to use the ALS slot system and play this animation on the left arm slot and the right arm slot only, and we will leave the rest of the body play the animation, whatever animation ALS will be playing at the moment. If we go into the animation graph, at the beginning of the animation graph, we can see where the slots, the ALS slot system is being used. You can see the slot for the left arm set to work only on the left arm, and the slot for the right arm set to work only on the right arm bones. So let's go to our animation montage and change this slot to the right arm slot. It kind of glitches out, we just need to close and reopen the montage. Now it's alright, and we're going to duplicate the slot and change the name to left arm. Save it. Now we need to call this montage from the code whenever we want to fire. So I'm going to go to my animation blueprint in the event graph, and here I'm going to create a new event. Add custom event. I'm going to call this fire. And whenever fire is called, I'm going to first filter this so we only execute the animation when we have the rifle in the hand. So I'm going to get the overlay state, and I'm going to run a switch on it. Switch on overlay state. And only when I have the rifle in my hand, I'm going to call the fire montage. So play montage, or montage play, and select the montage is fire ALS. The rest is okay. So what we need to do now is to call this event from the character, because only the character blueprint responds to input events, and we want to use an input button. We're going to create an input in the project and associate it with the left mouse button. So let's create the input in our project. Let's go to project settings, go to the input section, and in the action mapping section, let's add an action and call this fire. Yeah, let's call this fire action, so it's similar to the other to the naming convention that ALS is using. And I'm going to associate this with the left mouse button. Now we go to our character. In the Advanced Locomotion folder, we grab the ALS Anim blueprint, and here we can see that there is an option for the fire action input that we just create. So if I type fire action, this could be done in the controller blueprint too, but let's do this in the character blueprint. In here, I'm just going to call the animation blueprint fire event. So let's grab our animation instance, and we need to do a cache to the ALS animation blueprint, so we can access the fire event that only exists in the ALS animation blueprint. So let's search for fire. Now we can call the fire event here. We don't need this big node, we can convert to pure cache. Now let's test if this is working. First, I want to adjust the time to aim blend time, because this is too high. I'm gonna go for 0.2 pile, and let's play. Now I'm pressing the fire button, the left mouse button, and nothing is happening. That's because we placed that switch on node there. But if I grab the rifle and I press the fire button, now we can see that the arms are moving a little bit. If I aim and press fire, I can see that it's animating, but it's a bit too smooth. And if I aim in first person and press the fire, nothing is happening. That's because we have those nodes in the animation graph here. Those nodes are overriding the animation when we are aiming, because the animation is being played here at the beginning. The slot nodes are here, and after that, when we are aiming, we are executing these nodes, and these are fixing the hand in a position in front of the camera to align the sights, right? So it's overriding that animation for the hand. So we are going to add an extra node here to actually animate the right hand when we are firing. And the other thing I want to change is that the fire animation is looking kind of smooth. That's because the blend in time, if we go into the animation montage, it has an option for the blend in time and an option for the blend out time. and they're set to 0.25 seconds. For the blend out time, this is cool, but for the blend in time for a fire animation, this makes the animation look kind of smooth. So I like to have it at 0, so we have a abrupt change when we press the trigger. So let's save and test this now. Now it looks better, in my opinion. See, we can fire when we are not aiming too. And only the arms move because we are only playing on the arm slot. So how do we animate the hands despite the fact that we are telling the right hand to remain fixed in front of the camera when we are aiming, so the sights remain aligned? Well, this is the node that makes the right hand stay fixed in front of the camera. If we add a node after it that removes the right hand, we can animate the right hand in the way we want. This is already done in the original procedural aiming asset, so I'm just going to copy the nodes from there and place them here. If we go to the procedural aiming folder and grab the animation blueprint, these are the nodes that we want to copy. So I'm going to Control C, and here I'm going to Control V, and I'm going to connect this right after this node. But what is this node doing? It's moving the virtual bone for the right hand according to values that come from curves that I have inserted inside the animation sequence of fire, or in the fire animation sequence. So Unreal lets you insert curves inside animation assets. If I grab my fire animation sequence, you can see that I added 3 curves named aim fire backwards, aim fire roll, and aim fire up. I inserted those here so they can be used in the animation graph through these special nodes called get curve value. You specify the name of the curve that you want to get the value from, and they feed the value to whatever nodes that you want. By the way, if you want to customize these curves to make the fire while aiming feel the way that you want, you can double click in the curve and you get an animation, you get a curve editor, and then you can drag these values around as you want. So let's see if this is working out. And now I can fire while aiming. And if I want, for example, if I want to make the gun pitch upwards more, I can just drag these down further. Let's do something very different so we can see the effect when we play. It will only be visible when aiming. Now it's climbing more, right? Let's undo. For example, just to test, if I want to invert this, now it's going downwards. Now let's add the walk sway, because right now when we walk while we are aiming, the gun stays static in the middle of the screen. The same way that the procedural aiming project has curves for the fire animation, it also has curves for the walk animation. The only difference is that we are going to use the ALS walk animations, so we need to first copy the curves from my animations into the ALS walk animations, and then we can extract the curve values just like we're extracting here from the fire animations. Let's take a look at the curve. Let's open the walk forward animation, and these are the two curves that we're going to copy. Let's take a look at it. One for the horizontal movement and another one for the vertical movement. We can right click, copy, and then we go to the ALS folder, search for walk, and here is walk backward, walk forward, and paste. Now we have our vertical curve. Now the issue here is that the ALS animation has 34 frames of duration, and my original animation has 40 frames of duration, and it's important that the value at frame 0 be the same as the value at the last frame, otherwise the animation will jump when we are looping the animation. Since this curve was made for 40 frames, to loop in a 40 frames duration, it won't loop correctly in a 34 frames duration animation. So we need to scale it so the value at the first frame becomes equal to the value at the last frame. What I'm going to do is I'm going to select all keyframes, and I'm going to hold shift and drag middle mouse button until I have my first frame at my first keyframe at frame 0. Then I'm going to scale it down until this frame, which is the actual last frame. This frame isn't the last frame because this is just a repetition of this frame. So if I scale it down till this frame with the scale tool, I need to place the pivot at the first frame. Now it's on the first frame, so when I scale, the first keyframe won't move, and I'm going to drag this until the last keyframe is on the last frame of the animation. So now it's scaled correctly, but I want the animation to start back here just like it was in my original animation. It was at time minus 0.2 seconds. So I'm just going to turn off this, go back here again, and drag it with middle mouse shift and middle mouse button until I'm at the time of minus 0.2. Alright. So let's do the same for the vertical curve. Sorry, the horizontal curve. Copy. paste. The horizontal curve will be a bit easier because it starts on frame 0, has a keyframe on frame 0 and a keyframe on the last frame. So we just select the keyframes, go to the scale tool. The pivot is already at the first frame, so we just scale it down till the last frame, the last keyframe is on the last frame. So that's it. Let's save this. And it seems to be alright now. So now we go to the original animation blueprint of the procedural aiming project, and we are going to copy these nodes, Ctrl C, and place them here, Ctrl V. Now the vertical curve was connected to translation X, so vertical to translation X, and the horizontal curve was connected to translation Z, so translation Z. And let's see if this way is working. When we walk, we get the sway. When we run, we don't get sway because we didn't copy the values to the run animation, just to the walk animation. And if we walk crouched, we also don't get sway because we need to copy the curves to the crouch walk animations too. And also, if we walk sideways or backwards, we don't get sway because we need to copy the sway curves to all those animation sequences. Now let's copy the curves to the other walk animations too. Since I already scaled the animation, the curves to the duration of the ALS walk animation, I can just copy the curves from the ALS walk animation and paste them in the other ALS walk animation. So let's go to the walk backwards, paste, Ctrl S to save. Now let's see if this is working when we walk backwards. Yes, forward and backward, but not to the sides. So walk backwards, walk forwards, walk left, backwards. Let's paste this here. Let's just take a look if it's at the right scale. Let's see if they all have the same duration. Walk forward, 34 frames. Walk backward, 34 frames. 34, 34 frames, 34, and 34. So all those 1, 2, 3, 4, 5, 6, all those 6 sequences have the same duration. Let's test. I'm running, let's walk. so it's working. Now if you want to customize the curve to make the sway more to your liking, it's probably a good idea to add the cycles modifier to the curve. So you can just select the curve and then go to the pre-infinity and select cycle, and post-infinity select cycle. Now this looks broken because the last keyframe doesn't match the first keyframe. So I can just delete the last keyframe, and now it's a infinite loop curve, and I can select all the keyframes and drag them back and forward, and it will always loop correctly. I don't need to worry about the first and last frame anymore. Just remember that to use the cycles modifier, your last keyframe must have the same value of the first keyframe. So in this case it's 0.05. So 0.05 must be the value of the last keyframe too. And another important thing to notice is that we are in UE5. If you are in UE4, you don't get this option to copy and paste the curves from one place to the other. You need to go into the curve and copy the keyframes manually. So let's say you're in UE4 and you want to add a curve to this animation. You would need to first create an empty curve, and when you add them, they will come empty. So you go to the curve where to the other animation where you're copying the curve from, or the keyframes from, and you select the keyframes and copy and paste into your empty curve. And if you want to adjust the tangents, you're going to have to adjust, like I did here. You would have to adjust them manually too. So for example, this keyframe has tangents that probably don't need adjustment because they are flat, but these keyframes, I adjusted the tangents so it feels like the character's foot is hitting the ground. Now let's copy the curves to the run animations. Let's check the duration of the run animations. 20 frames, 24 frames, 20, 24, 20 and 24. So the run forward animations are 24 frames and the run backward animations are 20 frames. So we will need to scale the curve accordingly. Let's start with this. Now the problem is that it's now shortened. So now is a good time to use the cycles modifier. So let's test this. This is run backwards. So we just copied the vertical sway, and it's cycling without jumping, so it's working correctly. And we can copy from here and paste to all the other backward animations. But the cycle modifiers don't get copied, so we have to manually add them to the curve. I was getting some crashes when I was adding the cycle modifier to this curve, but I saved it and I started again and it stopped crashing. So you might get some crashes when adding the cycles modifier. So remember to save your stuff first. So this curves editor in Unreal Engine 5 seems to be a bit unstable at the moment. I was getting jumpy sway moving to the left and moving to the right, as if I didn't use the cycles modifier, but I did use the cycles modifier. I tried restarting the engine, it didn't solve it. It only solved it when I added the horizontal curves too. I don't know why. It's not the first time I get this problem. And also, if you use the undo function in the curves editor, you might get some crashes. So those seem to be some bugs in the Unreal Engine 5 that might be corrected in the future. You just have to be a little patient and save your work constantly. Now we need to copy the curves to the crouch walk animations, and the good news here is that all the crouch walk animations have 34 frames, just like the standing walk animations, so we won't need to scale any curves. So let's just go to the standing walk animation, select the two sways, copy, go to the first crouch walk animation and paste. And let's check this. We need to add the cycles modifier. And we don't even need to add it to the horizontal sway because it starts and ends with a keyframe. Control S to save. Now next animation. Control S, next animation. Now let's test. Crouch, walk. Seems we have the same problem, that the cycles modifier isn't working. Let's try to fix this. So to fix this problem, it seems that we just have to force the animation to update. So I just moved one frame back and forth and back to the same place, and then saved it, and now it got updated with the cycles modifier. So we need to do that to all these crouch walk animations. I'm just holding shift, middle mouse, clicking and dragging the keyframe to the side, not up and down. And then I drag it back, and then Ctrl S to save, and the animation sequence is updated. And now the cycles modifier is actually implemented. By the way, I like to have the snapping turned on, because it will guarantee that I always place the keyframes at the exact frame that I want. So let's test. Crouch. Something wrong still in the walk forward animation. So now the sway is working correctly. Now let's implement reloading. ALS doesn't have reloading, so we are going to use the reload animation from our project. Here it is. First I'm going to duplicate the original, and I'm going to name this ALS. I'm going to set this to not additive, because it doesn't run very well in the ALS system as additive the way it is right now. So we're going to change this to absolute, and we need to change the skeleton to the ALS skeleton. And we are going to only play this on the arms. and I need to make a animation montage out of this first. AM for animation montage. And let's change the slot to the right arm slot, duplicate, and change this to the left arm slot. Now we need to call this when we press the reload button. So right now we don't have a reload button. We need to add a reload action to our input settings. Input, just like we did before for the fire action, you're going to add a new action and call this reload action. And I'm going to bind this to the R key. Just going to press R on my keyboard, and now it's set. And this reload action can be called from inside the character. We can call this from inside the animation blueprint. So let's go to our character blueprint. And now we should have a reload action event here. From this, we are going to call an event, reload event that we are going to create in our animation blueprint, in the ALS animation blueprint. So let's first create a reload event, add custom event. Let's name this reload. And let's put our code that we are making, which is extra to ALS. Let's put this in a box and name this box SPA for organization purposes. So when this event is called, I need to run the animation montage, but the reload animation montage, but I only want to run this when I have the rifle in my hand. So I'm going to do the same thing I did here for the fire animation. So Control D to duplicate those nodes. And now only from the rifle output, I'm going to call the montage play node. And I'm going to select my new montage, which was called AM reload. All right. But we need to call this event from the action input in the character. So here in the character, we need to access our animation blueprint like we did before. So Control D to duplicate those two nodes. This is going to give me access to my ALS animation blueprint. And inside the ALS animation blueprint, I have my new reload event. So let's see if this is working. So when I press the R button, the character is playing the reload, but the problem is his left hand stays glued to the gun. That's because the ALS animation blueprint has an IK system that keeps the hand on the gun or on the object that you're holding if you want. So for the left hand, when enable hand IKL is set to 1, this node will be active and the hand will be glued to the object that you're holding. So what we need to do is set enable hand IKL to 0 whenever we play the reload animation. So we can do that by a modify curve node here in the animation graph, because this value comes from a curve. If I do a search on it, find references, set enable hand IKL, it comes from a interpolate node which is interpolating between two curves which are inside the ALS animations, and these curves define if enable hand IKL will have a value of 0 or a value of 1 or any value in between. So when we go to the animation graph and we place a modify curve node, and we choose the curve that we want to modify, in this case it is the enable hand IKL curve. Now we are modifying the value of enable hand IKL. The problem here is that the way it is set up right now, it's going to make it 0 all the time, and I don't want that. I want it to be 0 only when I'm playing the reload. So we are going to make use of the alpha pin one more time. I'm going to make a variable out of this, and I'm going to call this variable hand IKL alpha. Now with the alpha of this node, I can control if this node is active or inactive. So I need to set hand IKL alpha to 1 when I start reloading, and set it back to 0 when I stop reloading to turn off this node again. It's very important that the default value of hand IKL alpha is 0 and not 1. And let me correct the name. So let's go to the event graph where I have my reload event, and before I start playing my montage, I'm going to set this to 1, and after the montage stop playing, so I'm going to change this to duration. So the return value is the duration of the montage, and I'm going to call a delayed node here. So this is going to be delayed for the duration of this montage, and when it finishes, I'm going to set this back to 0. And now the left hand becomes free when we play the montage. If we try to reload while aiming, it doesn't look good. We could use this animation as additive, but it also wouldn't look very good in the ALS system of true first person. So we're just going to play the regular reload animation whenever we hit the reload button. So how do we stop aiming when we hit reload in ALS? ALS already has code for start and stop aiming. It's in the character blueprint, but not in the Anim blueprint. It's in the parent blueprint of Anim, which is right here, base character. If we go to the player input graph, there is an input action, aim action. which is called when we press the aiming button, which is the right mouse button, it starts aiming, and when we release the right mouse button, it stops aiming, and it uses this code that we are going to copy and paste. Control C. Now I'm going to copy this here. Control V. And before we reload, we stop aiming, and then we reload. Let's also, for organization purposes, create a box to group all the code that we are creating in the ALS blueprint. Alright, it's working. Now, before we add the ability to cycle between multiple sights on the same gun, let's add the ability to aim with the pistol too, because adding ability to cycle between sights on the same gun, especially with interpolation so it looks smooth, will make the code a bit more complex, and many projects might not need multiple sights on the same gun, but I guess most projects will need to have more than one gun. So let's start by adding the sockets to the pistol skeletal mesh, just like we did to the rifle. Let's do it for the pistol. We should add the sockets to the slide bone, because both the front sight and rear sight are connected to the slide bone. So, and another one. One is going to be called front aimpoint, and the other one needs to be called rear aimpoint. Again, I'm looking at the tip of the arrow here, so it looks right about here. So now the front side. I forgot, it's very important that the x-axis is pointing forward and the z-axis is pointing upwards. So we need to rotate 90 degrees, like so. And now the front aimpoint. And we need to rotate this one too, 90 degrees. Now, if you remember, we need to add the tags to the pistol component on the character blueprint. And the only problem here is that the pistol uses the same skeletal mesh component as the rifle in the ALS character. And we already added the tags for the rifle here, front sight, one front sight and one rear sight. And as a coincidence, those are the same tags that we need for the pistol. So if I didn't change anything here and played with the pistol, it would work. But we need a system that will change those tags in game, because I might have a gun that has only, say, only one optic sight, and we would need to then remove those two tags and add just the optic sight tag to this component, because all of the skeletal mesh guns that I use will use the same component, which is the skeletal mesh component. So let's do this now. I'm going to go to, so in ALS there's this function, update held object. This is called at any time that you change the mesh of the object you're holding. So this is how you switch guns in ALS. So when you switch to rifle, it calls this node, and when it switches to the pistol, it calls this node if you're going to hold your pistol with only one hand, and it calls this node if you're going to hold the pistol with both hands. So I'm going to add right after these nodes, I'm going to add a code to clear the tags of the skeletal mesh components, and then add the new tags that I want for that specific gun. So first, let's grab this component here and get its tags. It's an array of tags, and I'm going to call clear on it. This will empty the array, and after that I'm going to add items to the array. The first item, which is the first tag for the rifle, we are going to copy from the tags that are already here, because these are the tags that I want. So first one, front sight, and I'm going to add again for the rear sight. Control C, Control V. And I'm going to do the same for the pistols. And be careful, because it's only a coincidence that for the pistol I need the exact same components, but here you're supposed to add the components that you want for that gun specifically. So if you had a pistol that didn't have a front and a rear sight, only an optic sight, you would delete these and add just one add node with the tag optic sight _0. So this is the pistol, M9 pistol with one hand, and this is the same pistol with two hands. So we shouldn't feel any difference. Yeah. Alright, now that we are handling the tags correctly, remember that I was filtering the code to only execute when we have the rifle in our hands, the code that calculates the position of the sights. So we need to execute these not only for the rifle but for the pistol too. So both pistol execution pins go into this node here, and also we were filtering here for the fire code and here for the reload code. So let's test this. And now we can aim and fire and reload. But remember that we are using still the same animation sequence that we're using to reload the rifle, and this animation sequence wasn't made for the pistol. It actually wasn't made for this rifle too, so you might want to use your own animations for your guns here. Now let's test with the two-handed pistol, and we can aim and fire too and reload just like the rifle. And it seems we have a problem with the reload animation when we have the two-handed pistol in our hands. The pistol is not attached to the right hand bone, it's attached to a virtual bone on the right hand, and this bone looks like this virtual bone is rotating to the left when we press the reload button, but it goes back to normal when we are in idle. And it doesn't happen when we are crouched. When we reload while crouched, it plays normal. And also when we reload while moving, it also plays normal. Only when we are standing still and we reload that we have the problem. And it also doesn't happen with the one-handed pistol. Reloads normal. And the rifle too. Also, when I'm aiming and I hit the reload button, it plays normal up to the end when we are about to finish the animation. At the end of the animation, the problem appears. So since this problem is only happening with the two-handed pistol, and it's only happening when we are idling and we are standing and not moving and not crouched, we are relaxed. I went here in the overlay layer, overlay states. We know that it's only happening inside here because it only happens with the two-handed pistol. So I went here, the two-handed pistol states, and it's only happening when we are relaxed, not when we are aiming, so it's inside here somewhere. And it's not happening when we are crouched, it's happening when we are standing. And it's not happening when we are running or walking or sprinting, it's only happening when we are idling. So the problem comes from here. But all those nodes use the same animation sequence. They use the ALS props pistol 2H poses animation sequence. So if I select here, uses the same animation sequence, and this one also uses the same animation sequence, and this, even the crouched pose, uses the same animation sequence. The difference between them is that they use different frames inside this animation sequence. So this uses the frame at time 0. This one, when we are running, we use the frame at time 0.04 of the animation sequence. When we are sprinting, we use the frame the frame at time 0.08 seconds, and when we are crouched, we use the frame at 0.24 seconds of the animation. So let's open this animation. And you can see each frame is a different pose. and our problem is happening only here at 0. So I guess it's one of those curves that's causing this, and it's gotta be a curve that has one value at 0 and another value for all the other frames. So searching for this curve inside this animation sequence, I found that the layering hand R curve has the value of 0 here at the beginning, and then it changes to 1 and stays at 1 till the end. You can see better here. So at frame 0 the value is 0, and then it changes to value of 1, and it remains at 1 to the end of the animation. So when this value is 0, it's causing us problems. So I could change this value to be 0 too. This would solve our problem, but the problem is I don't know the reason why this value is 0 here. So I might be interfering with other stuff in the ALS project. So I'd rather change this value to 1 only when I'm reloading, and let the ALS code handle this value for the rest of the time. So instead of changing the curve, I'm going to place a modify curve node as we did before to be active only when we are reloading. So let's go back to our animation nodes, and I'm going to place another modify curve node here. And I need to modify the layering. Layering hand R curve. And I want the modified value to be 1, and we can use the same variable here, because this variable IK hand IKL alpha is being set to 1 exactly when we start reloading, and back to 0 when we end the reload. So I prefer just changing the name of this variable to something like modify curves and let's test this. Seems that it's fixed now. Another thing that I would like to fix is the distance from the camera to the pistol. You can see it's too close to the screen with both hands, and if we use the single-handed pistol, it also is too close to the screen. If we go to third person and we aim, the distance looks very cool. For the two-handed pistol too, looks cool, but remember that we are using a different pose when we are in first person. There are nodes running in the animation blueprint to align the sights that only run when we are in first person mode. So to see what it looks from outside when we are in first person, we can press F8 and we go outside while keeping the same pose, and you can see that the gun is actually very close to the camera, and that the elbow of the right arm is also on a weird place. We are going to fix that. Let's go to the one-hand pistol and see how it looks when I press F8 and look from outside. See, it looks very weird. The gun is too close to the camera and the elbow is in the wrong position. So let's fix this. So let's go back to the ALS character blueprint, and remember we had a variable called distance from camera. Its default value is 0. Let's increase this to 10 and see how it looks. Looks okay from first person, but if we go outside, it's still a bit too close, and if we change to one-handed pistol and go outside, it's too close. 2 centimeters is too close for a single-handed pistol. But if we switch to the rifle and we go outside with F8, it's already too far. 10 centimeters is too close for pistol and too far for rifle. So we need to have different values for distance from camera, one for each case here. So I'm going to set this back to 0, and I'm going to duplicate this and call this distance from camera rifle, and duplicate this again, call this distance from camera pistol 1H, and again now pistol 2H. So for the rifle, let's compile this so we can see the default values. For the rifle, 0 seems to be okay. For the two-handed pistol, 10 seems to be okay. For the one-handed pistol, we're going to have to increase this more, let's say 20. So now, after we select rifle, I'm going to set distance from camera to be equal to the value defined in distance from camera rifle. So I'm going to drag this, set distance from camera, and drag rifle here. So it's going to be the distance from camera rifle only when we select rifle. And when we select the single-handed pistol, I'm going to set distance from camera to be equal to distance from camera pistol 1H. And when we select the two-handed pistol, it's going to be set to distance from camera pistol 2H. So let's compile and test this. So rifle seems to be about the same, and pistol 1H, it's farther than it was before. Pistol 2H, also farther than it was before. Let's see from outside. I'm going to set this farther, and pistol 1H. Also further. So let's focus on the one-handed pistol for now. Going to go with 40 and see how it looks like. Looks okay from inside and from outside. Could be further. But the problem is that we are already reaching the limit of the arm. You can see that when we aim upwards, the sights get misaligned. That's because if I go outside with F8, I can see that his arm, his his arm is completely stretched and he can't reach the point where the sight would be aligned with the camera. You would need to stretch more. That's why it's misaligned. So a distance of 40 centimeters for the single-handed pistol is already too much, so we must decrease that. Let's try 35. Is still a bit too much. You can see that it misaligns a little bit when we are aiming upwards, but we are close. So let's try 34. File. F11 to go full screen. So 34 doesn't misalign. I'm going to leave it at 34. Let's check when aiming horizontally. It's not as cool as when we are in third person, but that's the only way we can get the sights aligned when we are in first person. It would look cooler if we stretch the arm more than this, but we will get problems when we aim upwards because the arm would stretch completely. So I'm going to leave this at 34 for the single-handed pistol, and for the two-handed pistol, let's see how far we can go. Let's try 20. Looks cool from inside. If we aim up, we are still in range. Aim downwards too. And let's see from outside. It looks cool, but the elbow, we must still fix the elbow. When we fix the elbow, it will look better. How can we adjust the elbow position? It can be adjusted here in the TwoBoneIK node. It has the joint target location pin. If we change the location here, we are changing the elbow location when this node is active, which is only when we are aiming. And we can also adjust the same values here in the details panel of the TwoBoneIK node, which I prefer. Instead of exposing this as a pin, I'm going to not expose this. This will make the animation graph cleaner, and now we can adjust the values from here. And I'm going to do this for the factoral location, which we are not using to here in the Anim Graph. So to make the Anim Graph cleaner, I'm going to not expose this, and I'm going to not expose the alpha pin too. So alpha pin, not exposed as pin, and I'm going to go ahead and do the same with this node, since we are not using the scale pin and the alpha pin of this node too. So I'm going to hide those pins to make the animation graph cleaner. So back to the TwoBoneIK. I can start adjusting the elbow position here, but I would prefer to do this while I'm seeing the character in the correct pose. So to do that, I can go in game. I'm going to select my two-handed pistol, and right now the character here is not responding accordingly. That's because we didn't select our character in game. So preview instance must be our character. You see that there are several instances because there are several characters here in front of us also using the same animation blueprint. So I need to select my own character, which is this one without the number in the end. So BP1 is the BP1, 2, 3, 4, 5, 6, 7 are all AI characters. I'm going to select the first one, which is myself, and now you can see that the preview here will mimic my movements. So if I select rifle, it's going to the rifle pose. If I select the two-handed pistol, it's going to the pistol pose. I can aim, I can go into first person, and if I aim in first person, you can see that the pose is different, as if I was watching from outside in first person. If I go to third person, see that the gun is held at a more distant position. Went back into first person and press Shift 1 to release my mouse so I can adjust values here in the panel. And since I have the, where is it? My TwoBone hand selected, the widgets will appear. This is for the effector target. We don't want to move this because it's already taking the position of the bone. What we want to adjust is the joint target location, which is here. So you can see that if this red axis here is the x-axis. So if I move on the axis, it moves to the sides. So I'm going to place it more outside, and the z-axis is up. So if I move in the z-axis, it's going up. And I want to place it a little more inside. And if I go back here to the beginning and I aim, still not in the place that I want, so I want to move this. Press Shift F1 again so I can release my mouse, and I want to move this more to the outside a little bit and see how it looks. So now it looks better in my opinion. I can place this way outside, see how it looks. Now it's not as cool. Now let's bring it back. Even more inside. I guess here is a cool place. Also, let's test if these values look cool also with the other guns in our hand. So let's test with the rifle. Yeah, the elbow looks cool. And the one-handed pistol. Yes, the position of the elbow also looks alright. So we can use the same values for the three cases, and this simplifies our lives a lot. I almost forgot. Let's add a white box to these nodes here, since we're adding them as extra to the ALS project, and name this Shooter Procedural Aiming. And also here in the animation graph, let's organize these nodes that we are placing here. Now we need to add the ability to switch between multiple sights in the same gun. So let's bring the optic sight from the pseudo procedural aiming. Let's open it and take a look at it. It's a small sight, and I already placed a socket and named it optic aimpoint on it. So if you're using your own sight mesh, don't forget to create a socket for it, name it optic aimpoint, and position it correctly with the x-axis pointing forward and the z-axis pointing upwards. So we need to place it in our character because the ALS guns stay in the character. So here's the component of the rifle. So we need to attach our optic aimpoint to this component. Right now we can't see the rifle. Let's make it visible by choosing the rifle mesh here temporarily, just so we can see it and place the optic sight correctly. So with this component selected, I'm going to add a new static mesh component. And it was already selected for me, the example optic sight. So let's place it on the gun. And now that we have it correctly positioned, the values of the transform are going to be kept even when I clear it. So now we cleared the component, there's no static mesh on it, but the transform of the component is still here. Same for the rifle, you can clear it. And only in game we are going to add a static mesh to add a skeletal mesh to the skeletal mesh component and a static mesh to the static mesh component. I'm going to rename this to just optic sight. Now we need to add the tag to the optic sight. So with the optic sight selected, I'm going to go to the tag section and add one tag, and it needs to be called optic sight underscore 1, because we already have iron sights on this gun and they are set to index 0. So the next index for this gun is 1. And now, in order to make it visible in game, when we select the rifle, we need to go to our update held object function, and only when we select the rifle M4A1, we need to make this component visible. We need to assign the static mesh to the static mesh component. So I'm going to call set static mesh, and the new mesh will be our mini optic. And when we select other guns, we need to make this optic sight invisible again. So we can do that inside the clear held object function of ALS, in which you can see that here the static mesh and the skeletal mesh from ALS, they already get cleared. So we need to clear our new static mesh component too. So I'm going to call set static mesh again, and this time I won't select anything, so any mesh that's selected will get deselected and the mesh will become invisible again. So let's put a white box and name it SPA here too. Compile and test this. Let's see if we can see our optic sight on a gun. It's very small. Yeah, should do it. It's there. And it must disappear when we select anything other than the rifle. So if I select the pistol, it can't be any optic sight. And we select the other poses too. Now let's go to the animation blueprint and let's go to the CalcHandTransforms function, and in the end we can see that we are hard-coded to always grab the index 0 of the array of transforms. But now, since we have 2 sights on the rifle, we must be able to grab different items from this array, because this array will have 2 items now. And we need a way to set current sight to the value that we want. We have nodes for that in the shooter procedural aiming project. If we go to the SPA folder and grab the animation blueprint, in the cycle sights event, we have these nodes that will handle the switching of sights. The first thing we need is to check if there's another sight on the gun. So if the gun has only one sight or no sights, there's no point in cycling between sights, so we're going to need this node. And after that we call find next index, which will just find which is the next index from the index that we are using now. And the last node is for interpolation, so it looks smooth when we switch from one side to the other while we are aiming. We are not going to copy this node for now, just going to worry about these 2 nodes for now. So Ctrl+C to copy, and let's go to the ALS animation blueprint, and in the event graph I'm going to paste them, and I'm going to create a new event called cycle sights, which will run these 2 nodes. Now that we are cycling the value of current sight, we can go back to our CalcHandTransforms function, and instead of setting this to 0, we are going to just get the current value of current sight, and we can delete these and connect directly here. And let me organize these, because I forgot to move these into the SPA category. So now we need a way to call this event from the character via an input action. So we need to add another input action to our project. So input gonna call this cycle sites action. And in the procedural aiming project, it was bound to the V key, but the V key is already taken in the ALS project, so I'm going to bind it to the next key, which is B. B is not bound in the ALS project, so we can use it. And let's go to our character like before, to the event graph. Here in the SPA box, I'm going to call our newly created input action cycle sites action. So this is going to be called when we press B, and from here I'm going to call this cycle sites event from inside the animation blueprint. So we need to access our animation blueprint just like before. Control C, Control V, and from here I call cycle sites. Let's compile, save this, play. Let's press B, and it's working, but it's not interpolating because we didn't implement interpolation yet. But if we switch to the second side and then we switch to the pistol, then it doesn't align anymore. But if we switch back to the first side and then we go back to the pistol, then it aligns. That's because the pistol doesn't have a second side and the code is trying to grab the second side of the current gun, so we need to fix that. We need a way to reset the current sight index whenever we switch weapons. If we go inside the ALS character, there's this function clear held object, in which this function is called when we switch weapons, and we are already resetting the weapon mesh inside here. So I want to reset also the current sight index from here. The current sight index is a variable that exists in the animation blueprint, and instead of setting it directly from here, I prefer to create an event here inside the animation blueprint that will reset the index, and then I call this event from here. So let's do that. Add custom event. I'm gonna name this reset site, and this is just a matter of setting it back to 0. We have last site too, but we are not using it for now because we are not interpolating between sites yet. File. Now from here I'm going to call that event. So we need our animation instance. I'm gonna cast to ALS animation blueprint, which is the animation blueprint that has the event that we just added. I can convert this to a pure cast, and from here I call the event. And let's see. Switch to the second side. Now go to digital, try to aim. Alright. Now we want to implement the part that makes the transition smooth when we switch sides. So this is already implemented in the original shooter procedural aiming asset, but we can't just copy and paste this node into the ALS animation blueprint because it won't work. And to understand how to make this work properly in ALS, we need to take a look inside our original CalcHandTransforms function. Remember that this is called only once in the original procedural aiming asset. This is called only once when we attach the gun to the character's hand. And at the end of this function, we set the current side to 0, and we grab the first element of the hand transforms array, because CalcHandTransforms produces an array with the transforms of each side on the gun. So if the gun has only one side, this array will have only one item, only one transform. If the gun has two sides, this array will have two items. So at the end of the function, we grab only the first item of the array, and we set hand location and hand rotation according to this transform. And hand location and hand rotation are the values that are used in the animation graph to actually place the right hand in front of the camera so the sides are aligned. And when we need to switch sides, we press the cycle sides button and we call this event cycle sides, which will change the index of current side. So current side right now is 0, and we press cycle sides and it gets incremented. So current side becomes 1 and last side gets the old value. So current side is now 1 and last side will be 0. And with that, you go to the interpolation part, which grabs the corresponding transforms of those two indexes. So we have the current transform and the last transform values, and we interpolate between them. And this is done every frame only until last transform becomes identical to the current transform, or at least very close. And then this stops looping. This loop repeats the interpolation once at each tick, thanks to this delay node here. But this won't work in the in our ALS system, because remember in ALS we changed the CalcHandTransforms function so that gets executed every frame. So the current transform value is changing every frame, so the target of the interpolation is different at every frame. So as a consequence, we never reach the target. So the value that we are using for placing the hand in front of the camera is never reach the correct value, which is the current side transform. So this loop never ends, and the sides never get aligned to the camera. How do we get around that? Why are we calculating the target value, the current hand transform every frame? Remember in the beginning of the video I said that it's because the camera in ALS keeps moving in relation to the head bone, and the gun also keeps moving in relation to the right hand bone. So that's why we need to calculate the hand transform every frame. But the movement of the gun in relation to the hand bone happens only for a short period of time, and then it stops. So the interpolation would catch up if the problem was just the hand moving in relation to the hand bone. The thing is that the camera never stops moving in relation to the head bone. So that's why this interpolation never reached the target. So the solution that I found was to postpone the incorporation of the camera values into the transforms to after this interpolation has finished. So let's go back to our ALS animation blueprint, and inside our CalcHandTransforms function we are going to change this to not run. This is the node that incorporates the camera position, the camera transform. We are not going to run this node now. We're going to connect this directly here, and we'll do the same for the iron sights part. And we are going to do the interpolation here, and after the interpolation we place that code that incorporates the camera position, and then after that we get the resulting hand transforms and feed the values to the animation graph. So now I'm going to grab this node from here, Ctrl C, copy it here, and make the proper modifications. If we compile now, we don't get errors because it's not the execution pin is not connected. If I try to connect this and compile, I'm gonna get errors. This error is because this variable doesn't exist yet in our animation blueprint in ALS. We can just right click and create variable last hand transform. It fixes that error, and this error right here is because our character is different. So we are grabbing the cycle side speed to use in our interpolation. So right now we don't need this. We can just hard code a value. I'm gonna make it 5. This is just controlling the speed of the interpolation. Later we create a variable out of this, and I don't need this delay node and this loop anymore because this is already inside a function that's running every frame. So I can just connect it straight here, delete these, and I don't need these nodes here because they are already being used outside after the function, so we don't need that. Let's go back here, delete these, delete these, and the output at the end we can connect both. So this is when the transforms are already equal, so the interpolation has already finished, and this one is when the interpolation is still running. So I'm gonna name this Interpolating. And I'm going to change this here. So instead of using the last index, I want to set the last transform directly here. So I'm going to grab current site and use it to get the current transform. And then I'm gonna set last hand transform from this. so we don't need these anymore. And let's move this inside the SPA category. And in the event graph, here when I reset the current site index, I'm going to reset the last transform to 0. And here, whenever last hand transform is equal to the current hand transform or is equal to 0, or I think I have to split this to make sure that this is 0. 0 location, 0 rotation, and scale of 1. I'm not gonna need these anymore. Whenever this happens or this happens, it skips the interpolation. And then we go out of that, and after that we grab the camera position. So get camera manager and get camera okay and get camera rotation. From these two, we make a transform. Rotation and location. And from here, if we already finished the interpolation, we are not interpolating, we are going to compose with the current transform. So let's get the current transform from the array. Get and current site. So we're getting the current transform and composing with the camera transform. And from that we need to subtract the pelvis offset as we did before. So I have to split here and subtract and get pelvis offset. And then we can set hand location from this and hand rotation from this. This is connected to the not interpolating pin here. And when we are interpolating, we want to use not the current transform, but the last transform, which is the value that's being interpolated inside here. So we are going to compose this with last transform. And now Same thing, we add the pelvis offset, actually subtract the pelvis offset, and we set hand location and hand rotation. And we actually don't need this variable anymore, so I'm going to delete and delete it from here too. And also we don't need any of these anymore. So we can connect the end of this to this, and the end of this to this. Let's test. And if we hit B to switch sides, and the transition is smooth now because it's interpolating. And this way works, both sides. Firing while aiming also works with both sides. I almost forgot to make a variable out of this, so we can control the speed of switching from one side to the other during the game. So I'm going to call this cycle side speed and move it into the SP category. And if you want, you can do with this just like we did for the distance from camera variable and have different values for different guns. Just make sure that the value of this is never 0. So let's check this, it's 5. If you set this to 0, it will look like the transition between sides is instant, as if you weren't doing any interpolation. And now we just need to organize our code so we make our lives easier. So I want to group all these in one single collapse node, which I'm going to call add camera position.